Hello and welcome back to Culver's Dev Blog. I really appreciate your patience in waiting so long for an update. It's been quite a while since my last post, so thanks for your patience. So today I'd like to talk about animation, and to do that I'd first like to kind of give some definition of terms and things for people who may not be too familiar with 3D modeling if you're maybe a beginner like I was not too long ago. So I'm here in Blender, 3D modeling program, and what we have is a very simple model of two cylinders and then an animation system inside, and I'll explain what these are in a minute. For you animators and professional artists out there, this is very simple because I'm by no means an experienced animator or 3D modeler, so just, forgive the simplicity of this. So, for the model itself, we have a couple things. We have the outside kind of skin of the model that's called our mesh, and if we go into edit mode here, you can see that this mesh is composed of kind of stretching a skin over this basic wireframe structure. These guys here are going to be our specific vertices, and they're going to have edges in between them running back and forth, and then the mesh is kind of what fills in the gaps, so to speak. And so let's say we want to make this move a little. Let's say this bottom cylinder is somebody's waist and legs, and this top cylinder is somebody's torso and upper arms and head. How do we get them to bend at the waist? So what we might do is add some bones, and that's what these guys are right here. So if you look at them, they actually do look kind of similar to what you'd expect of something called a bone. There's joints at the ends and in the connection between these two items here, and then these are the bones that run in between them. And so the joints are what really matters. The bone is just kind of there to provide a visual aid. And so what you're going to be able to do is then drag this guy around and move this bone based on rotating it with this joint. And so if we wanted to move this torso forward, we would say attach this mesh and these vertices to this bone and then move this bone forward. But how do we get that to play out over time? That's where this timeline down here comes into play. We have this timeline from a certain number of frames to another number of frames, and say we keep 0 as things are now, but then at time 10 we specify that this bone right here should be rotated 90 degrees forwards. Well, then when we play back the timeline through code, it's just going to interpolate smoothly between 0 and 10, and it's going to move the position and rotation of this bone and the meshes and like the mesh and vertices that are attached to it with that bone, and so everything will move smoothly forward. Okay, so it's all well and good to talk about how animation and models work on a high level, but how do we actually break it down in the code and make that smooth motion happen? So I'll start by going over the data and how we store it and break it down inside this class, the CZFX model class. We have our vertices that I showed you. We also have the original positioning of our vertices before they get any animation applied to them. That way we have a base reference of what we started from. We have the faces of our model, and those are going to be kind of what's between the vertices. We're going to have the meshes, and that's going to be the collection of a bunch of different faces. We're going to have materials, and these are going to be the textures that coat the skin of the model to make it look like something other than a gray blob, and as well as any shaders that we want to apply to the textures to make them look prettier, more realistic. We also have the joints, which I'm going to use interchangeably with bones because they're basically the same thing. We also have our animations. This is going to be what's called keyframes. These are going to be the like starting and ending point on that timeline I showed of a particular motion. That way, on any given timeline, we can just say, okay, a walking animation is from 0 to 15 seconds or frames, and a sitting animation is going to be from 60 to 75 frames, and that way you can store data a little more concisely. We also have just some other things here, most of which I want to call your attention to is these indices here. And the reason we have these indices is that we want to optimize how we store our vertices a little bit. In order to have the best result when we're actually rendering things, what we want to do is organize our vertices by the material that they're using. Materials are going to by far have the most data heavy like amount of processing involved with them. They're going to be the ones that are sending a large texture file across the boundary between memory to CPU to graphics card. And so we want to make sure that when we send them, we only do it once. And so we want to be able to send all the vertices associated with that material, all the animations associated with that material at the same time, so that we don't have to slow ourselves down by sending the same expensive textures and shaders back and forth across the rendering pipeline. So function-wise, we're going to start off with some basic preparatory functions, an initialize function to make sure that our variables aren't null. The prepare function is going to what's actually read in the model data from a file. I'm not going to talk about this in detail because this engine uses what's called a chunk-based format. It doesn't really support anything that we would use in a more modern setting. I really feel like that's something that they're missing. Maybe they were hoping that this chunk-based format that they defined would catch on more after they put this book out. I don't know. But in any case, it definitely hasn't. And so the details of how we read in the data from file and how that data is organized are probably not going to be too relevant to anything you might encounter in the real world. So instead, let's talk about some of the other preparation we have to do. The other main thing to note here is we have to set up the bones. This is going to set up our default positioning of all of our joints. Like joints don't really have an absolute position in space. I mean, they do, but the most efficient way to actually move them is by just having them all be parents of each other. Like you might have a forearm bone be parented or be a child of a upper arm bone, and that way when you're rotating your forearm, you're just rotating it with respect to its parent. And so the setup bones function is going to set up that whole joint hierarchy, and it's also going to set up the connections between a specific joint and the vertices it's going to be moving. So after we have that prep work done, we can actually call this sort of render function here, and that's going to render out our 3D model itself, the vertices, the meshes, the materials, but it's also going to handle the animations. So it's going to call our 3 animation functions here. Just the plain animation function is what's going to run the main timeline loop, like what you saw in Blender here. It's going to simulate this timeline so that we know where we are on it, and we know what animation we're currently in and how far along we are towards the next one. And then in animation prepare, which animation we'll call once per frame, what we're going to do is do some matrix math to actually calculate the position and rotation matrices for each joint in the animation skeleton. And so that way we can apply a specific rotation to a specific joint and all of its children. And then when that's done, we actually have to apply that out to the vertices, which is what the animation vertices function does. This is going to take those transform and rotation matrices that animation prepare created and adjust the vertex positions relative to the animation bones, and that is what will let us correctly move the skin, the mesh, and the vertices as we go. It's also going to update the collision system, what's called a bounding box, so that we don't have like an arm suddenly fly out to the side and then have stuff be able to fly through it. We want objects to collide properly with what their model looks like. So we have to update that information as well as we move the model around with animation. We also have some functions here after rendering the animation is done to render the bones and render the normal vectors on the faces of the model. These are just going to be for debugging, and that way if there's any kind of problem with how the animation is behaving or what the mesh looks like on the outside of the model, that way we can tell, we can have a little more information in whatever level editor or whatever we're using to be able to diagnose what's going on and see if we've got a face on the model flipped backwards or a bone isn't rotating the way we think it should properly. And so that's really the basics of how it works. Aside from this whole idea of organizing the vertices by what material they're using, there's not a whole lot of optimization. I'm sure there are plenty of other ways you could optimize it, but that's not something the book goes into. I will say, like I said, I think there is some info missing here. It's not really useful to have all these read functions without also knowing how to parse some of the industry standard file types like you would see out of Blender or Maya or 3ds Max. It would be nice. It would be nice for me to be able to know more about that. And also, even while the basic idea of having this skin and bone sort of model, the outside 3D model and the inside skeleton for animation, that hasn't changed much in the 10 years since the book was written, but I'm sure there's been all sorts of new developments that have been made in how specifically we go about that and how we go about simulating it that the book, being pretty old, doesn't capture. And so I'm sure there's plenty of more information that I'm really not doing a good job relaying here and that I don't know myself. So if you happen to know of any ways I could be doing this better, please comment, respond, share with your friends. I want to learn more, so anything you can do is very helpful. But for people who haven't seen this sort of thing before, I hope that this was a useful primer to how animation can work under the hood of an engine, and I'll see you next time.